Hi, mathletes. Welcome to week 7. This week, we're going to take a look at special right triangles. There are two cases. So we'll take a look at one case today. It's the 45, 45, 90-degree triangle case. And then on Thursday, we'll take a look at the second and final special right triangle case, which is the 30, 60, 90-degree case. I'm going to upload practice worksheets on each day. So make sure you complete those worksheets. It's very, very important that you complete Tuesday's practice and Thursday's practice because you want to make sure you understand each of the cases. So if you're getting a lot of the practice problems wrong, you'll be able to figure out which case you might have questions on. You can always email me with your math questions, and I'll also either open up the chat or the discussion board. I haven't decided which one. So just look on the sidebar to see which one's open, and you can post your questions. So a 45, 45, 90-degree triangle, it's named after the three angle measures. So 45, 45, 90. How this whole triangle came to be is if you think about a square has four congruent sides, it has four right angles. If you were to draw the diagonal from one vertex to the opposite vertex, here's a right triangle right here where you can see my mouse is tracing over. If this was a square, then all those sides are congruent. So we know from last week that if you have a right triangle and you know two of the sides, you can use the Pythagorean theorem to find that third side. So in this right triangle, the side length that I don't know is the hypotenuse. So I'm going to do leg squared plus the other leg squared and set it equal to that hypotenuse squared. Well, 1 squared is 1. 1 squared is also 1 again. So 1 plus 1, we get 2. And remember from last Thursday, we did a bunch of these Pythagorean theorem problems. We want to get c by itself. So I'm going to take the square root of both sides. And so c is equal to the square root of 2. So my side lengths, I have 1, 1, and then the square root of 2. So this is a pattern that you're going to find with this special right triangle. This is the relationship. In a 45, 45, 90-degree triangle, it is isosceles. That means that two of the side lengths are going to be the same, which we already know that. So the two legs are congruent. The hypotenuse is whatever that leg was, you take it and multiply by the square root of 2, and that's how you would find the length of the hypotenuse. For example, if the leg was 7, and the legs are congruent, so these two sides would be 7, and then the hypotenuse would be 7 times the square root of 2, which is just 7 root 2. So the theorem is the hypotenuse is the square root of 2 times as long as each leg. So the square root of 2, don't be intimidated by the radical. It's if you typed in the square root of 2 into a calculator, it's about 1.4. So it's a little under double. So the hypotenuse is a little bit less than double the length of the leg. Here's a summary. There's only really two cases with the 45, 45, 90. Either you're going to be given one of the legs, and if you're given one of the legs, the other leg is congruent. So there's two out of those three sides. And if you want to find the hypotenuse, you would take the leg and multiply it by the square root of 2. Now, what if you were given the hypotenuse? So what if you were given the side across from that right angle? Well, then you would divide the hypotenuse by the square root of 2. So you're either multiplying by the square root of 2 or you're dividing by the square root of 2. How do you know which one you're doing? It depends upon what you're trying to find. Here's a chart 45, 45, 90. So the sides across from the 45-degree angle, those are your legs. So those are always congruent. In your formula, you'll call them x. So if my leg was 5, the other leg is 5, and the hypotenuse would be 5 times the square root of 2. and I would write it as 5 root 2. If the leg was 24, well, the other leg's 24, and the hypotenuse would be 24 times the square root of 2. And I would write it as 24 root 2. Do you see the pattern? Let's do another one. If the leg was 7, the other leg is 7 because they're congruent legs, and the hypotenuse would be 7 times the square root of 2. Now, some people think that their hypotenuse is always going to have the square root of 2 in the answer, and that is false. Say, for example, the hypotenuse was 18, and you wanted to find the leg. Well, then you'd have to take this hypotenuse and divide by the square root of 2. So look at my leg. I took the hypotenuse and I divided by the square root of 2. So when you're working backwards in the chart, you're dividing by the square root of 2. But if you're moving forward in the chart, you're multiplying by the square root of 2. I always recommend that when you do the practice, it's a good idea to set up a little chart like this and have 45, 45, 90, and get in the habit of writing the formula out as you do. So have x, x root 2, and then look at your problem. What were you given? And that's the column that you would fill in. So that's how I'll show you in a couple of examples how to organize it when you do the practice. Example number 1. The first thing that I do is I sometimes like to fill in any missing angles. So in this one, I know that this is 90 degrees by that notation, and they gave me one of the angles. So I know that all 3 angles have to add up to 180 degrees. That would mean that this third angle is 45 degrees. So we are looking at a special right triangle, a 45, 45, 90 degree triangle. So what I do is I'd set up that chart. And I look, what side length was I given? Was I given the leg or the hypotenuse? Well, I look at where there was a number and I look at what angle it's across from. It's across from the 45 degree angle. So I was given one of the legs. Well, the legs are congruent. So this other leg has to also be 6. And if I want to find the hypotenuse, if I want to find the side length that's across from that right angle, I'm going to take the leg, which was 6, and I'm going to multiply by the square root of 2. So look at my table. This is how I like to set it up. I've got the leg, hypotenuse. You can even add in like the 45 degree part too. That's always a good idea. So 45, 45, 90. I filled in what the leg was here. Well, the other leg is the same. They're congruent in this special right triangle. And then the hypotenuse is the leg times the square root of 2. So here are all my missing sides. So y would be 6, and this side length would be 6 square root of 2. On number 2, it's a 45, 45, 90 degree. It's a special right triangle. I should mention, why are they called special? Well, they're called special because you only need to know one side length and you can find all 3 side lengths. That's why these are called special right triangles. A 45, 45, 90 degree triangle, I can set up my chart. What side length was I given? So I look at, where did I have numbers on which side? It was across from the 90 degree right angle. So I was given the hypotenuse. So I'm going to fill it in my hypotenuse column. Now I'm working backwards. I want to find what the leg is. If I want to find the leg, I'm going to divide the hypotenuse by the square root of 2. So I take this whole side length, you can see it right here, divide it by the square root of 2. And the radicals, anytime you have something divided by itself, it's going to cancel to be 1. And 3 times 1, the legs are each 3. So I've got 3, 3, 3 square roots of 2. Number 3, so it's a special right triangle. It's a 45, 45, 90. So I set up my chart. X root 2 is kind of the recipe that you'll see on most tests. What side length was I given? I look at where there was a number on which side, and it's across from the 45 degree angle. So I was given one of the legs, but if I'm given one of the legs, the other leg is the same because they're both congruent in this isosceles right triangle. So both these side lengths measure the square root of 3. Now I want to find the hypotenuse. I don't know the side that's across from that 90-degree angle. So if I want to find the hypotenuse, I'm going to multiply the leg by the square root of 2. So I've got the leg, which was square root of 3 times the square root of 2. Now, last Thursday, we talked about simplifying radicals, and we looked at that product property that states when you multiply square roots, you can condense it by putting one square root and multiplying the numbers that are inside of each of them. So this side length would be the square root of 6. Number 4. It's another 45, 45, 90-degree special right triangle. That is the only case that we're looking at today. But keep in mind that we're looking at the other case on Thursday. So the first thing that you want to do is look at what case is it? Well, this is a 45, 45, 90. What do I know? I know the side length across from the right angle. So this is the hypotenuse. So I'm going to fill it in my hypotenuse column. And I am working backwards. I want to find the leg. So I'm going to take this hypotenuse and I'm going to divide by the square root of 2. And for you guys, you can leave your answer like this. If you're going to take pre-calculus or later math classes later on, you might study how you don't want to leave a radical in the denominator. For this class, you can. It's okay. But just keep in mind if any of you are moving to level 1 or taking pre-calculus, then you might want to watch the video that I put up about rationalizing the denominator. So only if that's kind of the future path that you're taking. For this course, and especially for this benchmark, you can leave radicals in your denominator if they happen to appear in the problem. All right, the last one. A square has a perimeter of 28 inches. How long is the diagonal? I like this problem because it brings up a lot of nice pieces. It's got the perimeter, so you've got to remember what is perimeter. And then it has that vocabulary term diagonal. Now, they did not have to give us a picture, and I already filled everything in. But this is a problem that they could have just given you these 2 sentences, and you would have to be able to figure it out. The first thing that I do is I draw a picture. I draw a square. A square, all 4 sides are congruent. So perimeter means if I added up all 4 sides, if I added up all 4 sides and got 28, well, 28 divided evenly among those 4 congruent sides means that each side is 7 inches. And you can see how I labeled it. I also drew in the diagonal. Now, a square also has 4 right angles. So when I look at this triangle, this is a right triangle. And because these sides are congruent, the angles across them are congruent. So that means that these angles also are 45 degrees. So I am looking at a special right triangle, a 45, 45, 90-degree triangle. And so if it's a special right triangle, I can organize it with my chart, x root 2. What side, what did I know? Did I know the leg? Did I know the hypotenuse? Well, this is my right angle, and I don't know the side across from it. So I want to know the hypotenuse. That means that these are the legs. So the legs I know, and to find that hypotenuse, I take the leg and I multiply by the square root of 2. For these, when you leave your answers with radicals, you're finding the exact value. So that's something that we've talked about, the exact value versus the approximate value. If the directions asked you to round to a certain decimal place, then that's when you would pick up your calculator, and then that's when you would type in 7 times the square root of 2. So if you're just curious what it is as you go through the problems, you can definitely do that. I also recommend that just so that you get comfortable with square roots. So if you type that in, it's about 9.9 inches, which makes sense that it's the longest side because remember, the longest side is across from the largest angle. All right, here are some practice problems. So why don't you pause the video right now, try these problems on your own, and then hit play and you'll hear me talking through them. So I'll give you 5 seconds to pause the video. All right, welcome back. So let's go over these problems. I want to find this side length BC and also this side length AC. This is a special right triangle. It's the 45, 45, 90-degree case. And I was given one of the legs. Well, both legs are congruent. So BC would have to be, oops. I don't know why that doesn't want to move. BC would have to be 7 root 2 units as well. And the hypotenuse, I have to take that leg, multiply by the square root of 2. And then remember we studied that product property last week? When you multiply radicals together, you can condense them and condense it down to one radical by multiplying the numbers that are inside. So 2 times 2, I get 4. And then what's the square root of 4? It's just 2. And so 7 times 2, I end up with a hypotenuse length of 14 units. On number 2, it's another 45, 45, 90-degree triangle. You were given the side length across from the 45-degree angle. So that's a leg. The 2 legs are congruent. So that means that DE, or we can call it ED, is also 8. And to find the hypotenuse, I take the leg and I multiply by the square root of 2. So the hypotenuse is going to measure 8 times the square root of 2. Number 3, so it's just like that example number 5. Let's see if you got it. They told us that the perimeter of a square is 36 inches. So for that, did you draw a picture when you went through? So 36 divided by 4, what's that going to give me? Yes, you're right. Is this going to be painful? There we go. So each side length was 9. And we know that from the last problem, this is an isosceles right triangle. After I draw in this diagonal, so I'll draw in the diagonal. And you could have drawn the diagonal from this vertex to the other one. That's not going to matter. There we go. So it's got a 45, 45, 90-degree. I want to find that hypotenuse. So again, I take the leg and I multiply by the square root of 2. So that hypotenuse would be 9 root 2. Pay attention to the directions because sometimes it might ask you what's the approximate value or round, and you'll know that if it says in the directions to round. So the key buzzword is that word round in the directions, and that's the only time that you're going to be looking for your calculator to enter the radical in. Other than that, you leave your radicals in your answer because it gives you that exact answer. Have a great day, everybody. I'm going to add a lot of extra like YouTube tutorial links along with this video because this topic, it's just really great to see a lot of examples done out. And I'll upload also some practice worksheets. So remember that this is the unit, our last 4 weeks. You only have 4 more benchmarks and then we're done. This is a very important unit if you are continuing your senior year. And if you're taking pre-calculus, this is a very big unit. So make sure that just let me know if you want more practice or if you need anything. Have a great day, guys. Bye.